Okay, so to be able to solve for a pyramid that is 75 triangles wide, let's first start with the simplest solution, which is one triangle. That is 1 unit in length. We'll call this right here 1 unit. Obviously, the only number of triangles we can make in this is 1. So let's go to a triangle that is 2 units wide at the base. And if we're only going to focus on the upward facing triangles that are only 1 unit in length, we can make 1, 2, 3. That's 1 plus 2. We got this old one, and then we have 2 new ones right here. And if we go to a triangle that is 3 units at the base, we have 1 plus 2 plus 3. That's 1 plus 2 plus 3. So you can see we have a pattern emerging here, which is that you can write the number of triangles that are 1 unit in length as the sum from 1 to n, where n is the number of units in the triangle, as the sum from 1 to n of I, which is, for the scenario where n equals 3 is equal to 1 plus 2 plus 3. And so for a finite sum that is arithmetic, you can summarize that as n times n plus 1 over 2. And we'll call this triangular number n, t sub n. So, but obviously with these other triangles, we can make triangles that are multiple units in length. So here we can make, for a triangle that is 2 base units in length, we can make 1. And for this one, we can make 1, 2, 3. So you see here that it's just equal to the t sub n of the previous, the next smallest triangle. So let's summarize what we found up here. So for a base length of 1 unit, the number of upward facing triangles in the pyramid is equal to t sub n. But if it's 2 units in length, then it's equal to the t sub n from the next smallest triangle, which is t sub n minus 1. And this pattern continues all the way down to the nth unit, t sub n minus 2, n units. And this is equal to t sub 1, which is just 1, 1, 1. But we can also make downward triangles. So let me redraw this triangle here that is 2 units at the base. We have one downward triangle that is 1 unit in length. And then if we do the same thing for 3, we can make 1, 2, 3. And if we go to the 4th one, just for good measure, we can make 1, 2, 3, 4, 5, 6. And you see here, it's the same pattern that we had up here, just shifted down 1. So let's see here, we have downward. And this is equal to t sub n minus 1. These two numbers are the same. These two numbers are the same. These two numbers are the same. And then it continues on down from there. So then also we have to take into account that at n equals 4, this triangle is n equals 4, we can also make a downward facing triangle that is 2 units in length. So that we can make one triangle that is downward facing and 2 units in length. That is also equal to the triangle, this number, which is 2 triangle numbers smaller than this one. So it's equal to Tn minus 3. Because relative to this one, it is two smaller, so Tn minus 3. And this pattern continues all the way down, 0. And once this number right here gets bigger than n, it's just zeros all the way down from there. So if we take this pattern that we have right here and we sum up all the upward terms plus the sum of all the downward terms, we get something, after a little bit of math magic, n times n plus 2 times 2n plus 1 all over 8 rounded down. That's what these guys mean. They mean rounded down. So back to the original question. So if n is 75, we have 75 times 77 times 151 all over 8 rounded down, giving us a grand total of 109,003 triangles. And that's your answer.